pattern. Okay. Now remember, when you talk about the linear number pattern, right? So obviously you will have the general equation of Tn equal to an Tn equal to a plus n minus 1 times d. Now the linear number pattern is taken from the linear function. Okay, that's the first thing. Now when you're dealing with the linear pattern, you have to know that the straight line, you have to know that the first different is the one that is the same, right? That's what makes it different from the quadratic number pattern. Now, when I have, for example, T1, T2, T3, T4, all right? The first different, which is D1 here, is the one that will be the same, okay? D11 and D12 and D13. So this means that D11 would be equal to D12 would be equal to D13, right? Once you see something like that,
So
yes.
I just wanted to say, you placed T4 as T3 by accident.
Oh, thank you, man. Thank you. So here, yeah, thank you. So you understand this now?
Yes.
Right.
That makes sense now.
So
it's a lot easier than the method that I was using before. Before using this, I used reverse engineering principles to use terms,
yes,
which is basically just opposites. Which that is not reliable because you will not get the same answer each time. Because if you're using BODMAS, and then if you're not using BODMAS, it will give you different answers, of course.
yes.
So this is a lot more reliable, and this is accurate.
Yes, yes. So from here, let's just quickly have an example of a linear function. Let's say we have, let's say we have 2, 4, 6, 8, 10. Right? Let's say we have something like this, right? And then the question say, calculate Tn, right? By the way, let me just quickly explain the formula. So A is the first term of the sequence. So this is the first term, okay? So this is the first term of the sequence. N, I already explained N. N is the position of the term in the sequence, all right, or in the number pattern, all right? And D is the first difference, okay? So this is the first difference, okay? Now, once you have this, and then once you understand this, that's the first thing to understand, okay? Now, let's quickly do this. Let's say here they say find Tn. So obviously the first thing that we have to do, we have to find the first difference. So it's 4 minus 2, right? Which is T2 minus T1. Remember, I said you can use Tn plus 1 minus Tn, right? This is like the formula that you have to use to find the difference, all right? So that is 4 minus 2, that is 2, obviously, right? And 6 minus 4, that is 2. And 8 minus 6, that is 2. And 10 minus 8, that is 2 also. Okay, you can see that the first difference is the same. So since the first difference is the same, you can conclude by saying this is the linear number pattern. Okay, so now you can conclude this is the linear number pattern. Now let's find now what we call the general equation for this. All right, so let's use the general equation. So it's Tn equal to A plus n minus 1 times d. All right, so A is the first term in the sequence. When you come here, the first term in the sequence is 2, right? It was a coincidence that the first term is 2, also the first difference is 2. That is the mistake. That doesn't mean that it's always be like this, right? Be careful with that. Okay, so the first term is 2, so that means you have Tn equal to 2 plus, okay, and then you leave n like that, because what we want to find here, we want to find the formula, we want to find the general equation. So this would be n minus 1, and the first difference is 2, so times 2. At most cases, I would suggest that you take this d to the side, right, to make everything simple for you to understand how to.
Yeah, because then it's simpler. Because then you can it's basically just BODMAS. It's simpler using
Yes,
BODMAS.
100%. So let's say Tn equal to 2 plus 2 into n minus 1. So you apply the BODMAS as you said. So this is Tn equal to 2 plus 2 times n. That would give you 2n. 2 times minus 1, that would give you minus 2. And then Tn minus equal to 2. Minus 2 minus 2, that is 0. So this is 2n. So this is the general equation for this. Okay. So if I want to find the first term, I have to get 2. So if I'm plugging 1, I have to get 2. If I plug in T2, I have to get 4. Let's prove that if that is the case. So T1 is equal to 2 into 1, and then that is giving you 2. And T2 is equal to 2 into 2, and also that is giving you 4. Oh, so this is the formula that you can use to find any term in the sequence. Okay?
It's actually really simple. It's really simple. It's just equations. It's just equations.
Yes.
It's simple equations.
Now there's also the trick that they love to use in an exam. They also the trick, for example, if they can give you here, they can give you that the last term, right? Maybe the last term is and they say 200, right? And then they say what is the how many term in the sequence? They can put this question like this. They can ask you how many term in the sequence, or they can say what is the last term in the sequence? Okay, what is the last term? Okay, so if they say how many term in the sequence and they gave you the last term, so remember in the formula you used to plug in the position to get this number. Okay, now they gave you Tn, so you can use this form. Let me just write it near this. So you can use this formula of Tn equal to 2n, right, to get what is the term right here. So you can plug in 200 here and have 2 into n, and then you calculate n, because n would give you the position. And this is if this is the last term, hence that would tell you that we have this term in the sequence. Do you understand what I mean?
Yes, it makes
Any
sense.
question here?
No, that makes sense because it's like I said, it's just equations, simple equations.
Exactly. So here you just divide by 2 on both sides, and then you have n being equal to 100 position. So that means we have 100 terms in the sequence. So they can try to trick you like this, right? Okay,